Welcome back, y'all. Here we go again. We're going to try to do this synthetic division again, and we got some problems we want to work on. This one right here says use synthetic division in the remainder theorem to find f of negative 1/5. Okay, so now you don't like fractions, you don't like synthetic division, you want to plug negative 1/5 into x and find f of negative 1/5, you can. But I can tell you right now that the synthetic division is going to be easier to find this. I promise. You won't have to deal with too many fractions. How is that possible? Well, let me show you. So we're going to do synthetic division. I've got the numbers. I pulled the coefficients off, and I pulled the negative 1/5 down. And here's the little trick. Multiplying by negative 1/5, and I'm going to write that over here. Multiplying by negative 1/5 is the same as dividing by negative 5. So we're going to use this little divide by negative 5 to make this problem a whole lot easier. So let me show you. So our first thing we do is we pull down our negative 5, and then technically we multiply, right? That's our technical way of doing this. We're going to multiply that. Well, if we just look at it as dividing by negative 5, we've got 5 divided by negative 5. Well, that's negative 1. And then I add these two numbers. And then I do negative 30 divided by negative 5. Well, that's positive 6. And then I put those two numbers together. And then I'm back to 5 divided by negative 5, which is negative 1. I have a 5 there. And 5 divided by 5, negative 5, is negative 1 again. And my answer is 1. That's my answer to the question. F of negative 1/5 is 1. Now, if you want to go ahead and plug in that negative 1/5 into each one of these x's and raise them to those designated powers, you just go right ahead. But this was a whole lot easier. So that is why we use synthetic division sometimes to do the f of a number, because synthetic division can make things easier. Okay, so this is just one of the little things that can happen with synthetic division, okay? But this is not our main purpose, but it's related to our main purpose. It's related to our main purpose. Our main purpose is to get 0 right there. That's our main purpose. And our main purpose is to find numbers that when we plug them in, we get 0. And that's what we're talking about. Remember what a 0 is. This goes back to the very beginning. One of those definitions, a 0 is a number. When you plug it in, you get 0. So if I plug in a number and I get 0, that means that number is called a 0. Okay, and remember, synthetic division helps us find numbers that we plug in. We can either do synthetic division or we can plug them in. Either way, to find out if something is a 0 or not. Now, the advantage of doing synthetic division is what you get in what those other numbers are that you get. If you just plug in and get a 0, you're still going to have to divide. Still going to have to divide. So you might as well just do the division. Okay, so here we are. We're going to decide if a number is in fact a 0 of the polynomial based on our synthetic division. So yes, you can plug in 4, but you'll have more information if you will do synthetic division. So we're going to do synthetic division with this particular problem, and we're going to use 4. 4 times 2 is 8, and that gives you negative 5. 4 times negative 5 is negative 20, and that's going to give you negative 32. Is that right? Okay, just making sure I don't screw up. And then 4 times negative 32 is going to be a negative. That's not a 2. That's going to be an 8. And negative 128. And so then when I do subtraction, I get negative 42. So the question is 4 a 0? Well, the answer is no, because this is not 0. also known as the remainder, is not 0. So f of 4 is negative 42, not 0. That's what's significant here. Okay, let's do another one of these. Ooh, complex numbers. We can do synthetic division with complex numbers. We're going to do 1, negative 6, 10, and we're going to divide by 3 minus I. Okay, so now how do we do this? Well, we're going to use a little scratch paper over here, but we can do this. You've got to remember how to multiply with 3 minus I. So we know we're supposed to bring down the first number, and then we multiply 3 minus I times 1. Well, that's just 3 minus I. And we combine these. Well, the minus I doesn't have a like term, because remember, there's no I in negative 6. So, but the negative 6 plus 3 is negative 3. Okay, and so then I'm going to do 3 minus I times negative 3 minus I. And let's see what we get. So I get negative 9 minus 3I plus 3I plus I squared using my FOIL. Those cancel out. Remember what I squared is? That's negative 1. So negative 9 and a negative 1 is a negative 10. So I get a negative 10 right there, and that gives me a 0. So now the question is K 0? Yes, it is. That's your answer. Yes, 3 minus I is a 0. Because when I did synthetic division with it, I got 0. Right? A little scratch, a little FOIL, little remembering stuff we did from the beginning. It's coming back, y'all. It's coming back. Okay? All right. Now, let's just finish this up real quick. Let's think this through. All right? If you plug in a number and you get 0, then x minus that number is a factor. And that number is also called a 0. Okay? Gotta get this factor thing in here. All right? If this is a factor, then that number is a 0. And we can divide to find more factors. It goes back to what we were talking about at the very beginning of this series. Whereas when you divide, you get 0, you can divide again, get more factors. Okay, this is the factor theorem. All right, so now we can use this factor theorem and synthetic division to decide if a second polynomial is a factor of the first. Okay, so is this a factor of the first? Well, if I divide by negative 3, notice there is this sign change going on. I'm going to show it to you. There's always this little sign change going on. We've got a factor, says x minus, but then the number doesn't have the minus. Okay, so if this was x minus a negative 3, so there is a sign change between the factor and the number. All right, so we want the sign change is going to be negative 3. So we're going to do our division. Oops. 4, 9, negative 2, 26, 13. We're going to do our division with negative 3 because there's a sign change from the factored form and then the 0. Okay, that's the factor, that's the 0. We always divide by the 0. Now, this is one of the things that everybody messes up on with synthetic. So make sure you're dividing by the potential 0. So I get negative 12, 9, I get negative 21, and I get negative 15. So the question is x plus 3 a factor? And the answer is no. X plus 3 is not a factor. Why? Because f of negative 3 is not equal to 0. Or f of negative 3 is equal to negative 2, not 0. Goes back to that remainder number. Okay, this is a lot, but get into your homework and see what you can come up with. This is about it for this assignment. And so this is synthetic division, y'all. It's just math. Y'all have a great day.